Picture this. A fault hits a major power line feeding one of China's biggest tech hubs. In a traditional grid, that could mean minutes of darkness and millions in losses. In 2025, in Shenzhen, the grid detected the fault, isolated the damaged section, rerouted power, and restored supply in 17 seconds, with no human touching a single switch. That's a self-healing grid. And China wants this AI-enhanced distribution architecture rolled out nationwide by 2030. In this video, we're going inside that system, how self-healing actually works, how AI changes the game, and what China's 2030 vision tells us about the future of electricity. A self-healing grid is a power system that can detect faults, isolate the problem area, and restore power to as many customers as possible automatically, often within seconds. You'll often hear one key acronym, FLISR. That stands for Fault Location, Isolation, and Service Restoration. Here's how it works in 4 steps. First, detect. Sensors, relays, or smart meters detect that something is wrong, a short circuit, a broken cable, a tree on a line. Second, locate. The system compares which devices saw the disturbance and which did not, narrowing the fault down to a specific segment. Third, isolate. Remote-controlled switches or breakers open around the faulted segment, cutting off only the damaged section. Fourth, restore. Then the system closes tie switches that connect to alternate feeders, rerouting power around the fault to restore service to as many customers as possible. In a conventional system, operators might do all this manually. In a self-healing grid, that logic runs automatically, either in a central distribution management system or increasingly at the edge. To understand how this scales, it helps to break the self-healing grid into 4 building blocks: field devices, communication network, control logic, and self-prevention versus self-recovery. Modern distribution grids are no longer simple radial trees. They have multiple supply paths, distributed generation, storage, EV chargers, and flexible demand. AI and advanced optimization help in several ways: pattern recognition, restoration strategy search, and learning from experience. AI also supports self-prevention, like predictive maintenance and DR coordination, deciding when to use local generation or storage after a fault. This is the conceptual backdrop for China's 2030 self-healing vision, not just automating switching, but using AI to orchestrate a much more complex, renewable-heavy, bidirectional distribution grid. China's smart grid roadmap has been explicit about self-healing for over a decade. By 2030, the goal is a smart power grid with self-healing capability. In 2025, the Chinese government unveiled a national plan on AI plus energy integration to drive the green transition. This plan highlights that AI is expected to enhance grid reliability and flexibility, especially as China pushes more renewables and faces growing data center and EV demand. China's new power system concept describes a grid where renewable energy is dominant and digital and AI technologies are deeply embedded. China's vision is not just on paper. Let's look at a concrete example. In 2025, China's Southern Power Grid reported the country's first AI-powered self-healing power grid system operating on a 110 kV section serving Shenzhen's Luxiandong area, a major tech hub. The system monitors the network in real time, uses AI algorithms to automatically detect and locate faults, calculates restoration strategies, and executes switching actions without human intervention. In a test scenario, when a fault occurred, the system isolated the faulted section and rerouted power to healthy lines. It restored supply in about 17 seconds, compared to several minutes under conventional procedures. This pilot matters because it shows AI is moving from offline planning into real-time operational decision-making, and self-healing is being executed at scale. For self-healing to work at a national scale, you need more than clever algorithms. You need infrastructure. China has been upgrading substations and distribution networks with digital protection and control systems, condition monitoring sensors, and automated feeders. To support fast, reliable self-healing, utilities increasingly use private LTE and 5G networks to link substations, field devices, and advanced metering infrastructure. On top of this, AI platforms aggregate real-time and historical grid data, weather, load, and DR forecasts, and equipment health metrics. Even with all this progress, there are big questions to answer before 2030. Putting more intelligence and autonomy into the grid raises obvious concerns. A larger cyber attack surface and potential consequences if AI behaves incorrectly. Operators are not being removed. Their role is changing. They must understand and oversee AI recommendations, and training must adapt to supervising increasingly autonomous systems. Moving from a few flagship projects to nationwide self-healing involves upgrading vast numbers of substations and feeders, standardizing architectures, and ensuring coordination. Self-healing is moving from a nice-to-have feature to a core requirement, especially as societies become more dependent on 24/7 digital infrastructure. AI is becoming embedded in the grid's nervous system, helping it sense, decide, and act on timescales that humans can't match. China's 2030 vision is a real-world example of how a country can combine massive renewable build-out, rapid electrification, and high reliability using digital and AI tools. Future grids will be more sensing-rich, automated, and self-healing than anything we've seen before. If this 17-second restoration story from Shenzhen is a glimpse of the future, we're heading toward a world where outages are shorter, restoration is faster, and the grid behaves more like a living system than a static machine. There are big questions around cybersecurity, AI governance, and how much autonomy we're comfortable giving critical infrastructure, but the direction is set. If you want a follow-up episode diving into the nitty-gritty of FLISR algorithms, how microgrids add another layer of self-healing, or how other countries' approaches compare with China's, drop a comment below, hit like, and subscribe so you don't miss it. Thanks for watching, and see you in the next one.